Hello, I would like to do a quick sound check before we start. If you can hear me, please type yes in the questions tab. Okay, we're getting some yeses coming through. Hello and welcome everyone. Thank you for joining us today for our virtual meetup titled Getting Your Supply Chain Back on Track with AI. My name is Shabar Pula and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Karthik Guruswamy is a Senior Principal Solutions Architect and Business Data Scientist at H2O.ai. Before I hand it off to Karthik, I'd like to go over the following housekeeping items. Please feel free to send us your questions through the sessions, throughout the sessions via the questions tab in your console. We'll be happy to answer them during the Q&A at the end of the meetup. This meetup is being recorded. A copy of the meetup recording will be available after the presentation is over. And without further ado, I'd like to hand it over to Karthik.
Hi, everyone. Welcome to the talk, to the meetup. So let me see if I can share my screen here. Yeah, there we go. Yeah, so we're going to be talking about this important topic, getting your supply chain back on track with AI. We're going to cover a couple of important things here. First is what is H2O doing regarding response to COVID-19? And also we'll look at supply chain in the COVID-19 era and of most recently, the social unrest. So we'll look at how do you manage a supply chain in difficult times? And then the rest of the topics are here. And then at some point we'll go to a demo and then we'll be going to a Q&A at the very end. So how is H2O contributing and solving COVID-19? You can see a quote from the CEO and founder of H2O, Shri. We're focused on data science and help in saving lives and to do good for the humanity. And currently we're working with hospitals and staffing predictions and ICU transfers and generally predicting the spread of COVID-19. And I'll go through some of the initiatives around that. And most importantly, hospital supply chain. So we started with hospital supply chain that's connected to COVID-19. And now we are expanding it to the core of the COVID-19 predictions across multiple verticals. And supply chain being one of the most important, problem space right now because of the uncertainty that's around so many different topics, just beyond COVID-19. And so basically from H2O, we have been evaluating global and open health data sets to determine patterns. And then, as you know, H2O has data science experts that are contributing to the knowledge to solve the testing problems in the pandemic, right? And also H2O has a lot of AI platforms, and two of which will demo today, the driverless AI and the Q platform. And finally, we'll look at solutions around AI, just not supply chain, but going beyond supply chain. So as you all know, there's unprecedented disruption to supply chain happening last few months. It's kind of the black swan moment for supply chain right now, right? And businesses are, trying to cope with it, but the recovery it's going to be very difficult. Just reading all the news that's coming out of so many newspapers, right? I mean, and also TV channels. And you see, unless the business act on it proactively, the right tools and approach, the recovery is going to be very difficult for business, right? We see disruptions across models and process around manufacturing, warehouse management, transportation, distribution, logistics, right? It's a long list of supply chain building blocks that gets stuff on the shelves, right, and to the and to your home, right? And so we even see things like, cash flow forecasting, also, part of the supply chain as well, right? So through and post COVID-19, as you might have already experienced, right, there's going to be a diminished or sudden increase in demand for consumption of household and industrial goods. As you know, groceries, PPE, baking goods, alcohol, frozen food, right? The demand is going up, and then you're going to see demand going down on other things as well. So basically, the whole situation has changed. And even if we recover, there is also a possibility of a second wave. And I think, and I don't think anyone is really prepared for that, right? From a supply chain perspective, from a supply chain perspective. Part of the issue that businesses are struggling with this problem is because a lot of businesses, even if you use AI and ML, the models have been manually crafted with agile projects, right? Like maybe like a 3 or 6 months projects, wherein a bunch of data scientists look at the data, do some forecasting, or build some models around supply chain. However, the models only work if the underlying assumptions on the ecosystem and the macroeconomic environment has not changed. Let's say in your model, you have not included any of these, then when that changes, then your model breaks, right? So which means you got to start all over again. You got to build new features, you have to go and create it, and then you have to back test it. And then, and also the supply chain models, it's not one size fits all, right? It changes from not only from SKUs to categories, but it also changes from state to state and country to country, right? And something like COVID-19 happens, unfortunately, we don't have historical data, right, to go back and build those models. Maybe subprime crisis, you can probably go back to many years ago, but not, a pandemic, right? We don't have the data. The last pandemic that happened was in the last century, right? So we don't have the data. So obviously, you cannot afford to build new AI and ML models with the same methods and timelines. That situation is changing every other week as well. So let's say you have historical data just for the last few weeks. Then when the situation changes, right, that's not good enough. So you need to come up with something better, right? So basically what it really boils down to is that time to train and deploy short-lived models with the highest accuracy week after week becomes extremely difficult, right? And the talent, especially not necessarily the data scientists, but the domain expertise that was generally used for traditional models is not suddenly reusable, right? Nobody knows what to do. And the third thing is that even if your models are predicting something, that this is how your inventory is going to change, you really want to get a really quick insight into what's actually impacting your model prediction. So the trust is extremely important. So it really comes down to time, talent, and trust that most businesses are missing today to build good supply chain models around COVID. From the H2O side, I mentioned just a little bit about the talent in the team. H2O has some of the top, Kaggle grandmasters, the world's best Kaggle grandmasters, and they've been competing with, Kaggle competition, not just just any competition, but especially they were focused on COVID-19, the global forecasting contest on Kaggle. And we've been consistently on the leaderboard and predicting what's going to happen next week on which region, right? So, and we're going to talk about a little bit of what they did and why our models are on the leaderboard. And then we'll talk about how to incorporate this model into supply chain and other parts of the business, okay, in a second. So how do you build models around COVID, right? So the most important thing to remember is that if you can predict COVID, and at some point, probably the social unrest as well, but we won't talk about that in this meetup, right? So if you can predict COVID in the next, few months across every country and every county, right, in the best possible way, then that gives you, that's a really good building block to include in your existing model, right? So the Kaggle grandmasters have been using power growth models for the competitions. And just to give you a small sort of like a introduction, you can look at on the right side, the power growth models are basically, this is like how COVID infections are, growing. And you can see it's basically made up of, an exponential growth initially, followed by a couple of polynomial growth at the end. So taking a curve like this and then fitting different exponential, polynomial, functions on top and deriving the coefficients would be something called as a power growth model, right? And we've been extremely successful with this, right, in the competition. So that's one way to forecast, because you take disease forecast and you're able to come up with a formula that's using exponential polynomial, and you got yourself a nice equation or a formula to predict what's going to happen in the next few weeks or months. The same thing could also be used for the second wave in some way, and we'll talk about that later. Okay. The second way to address COVID, predictions is using epidemiological models such as SEER. SEER stands for susceptible, exposed, infected, recovered, and dead. So it's kind of like a state-driven model. The originally came with some differential equations, and then you have all this free parameters that you can take and try to fit in, right? So some percentage of susceptible become exposed, and some percentage of exposed become infected and either recover or they unfortunately die. And the movement across these different states is really governed by mandatory social distancing or self-quarantines or lockdowns, and that actually governs that model. So what we have done right now is we have incorporated the SEER model that's incredibly popular right now across epidemiological studies. And we have taken that and incorporated into a driverless AI software, right? So which means that you bring in some upper and lower bounds of some values on all these different states. And then we run an optimizer inside to find the best fit. And then we look at the actual, infection rate. And then we build a model like a GBM model or an AutoML model around the residuals. So now why we are doing all of this is because once you have the COVID predictions nailed down, then your existing models that haven't used that exogenous value, data can be enriched by the predictions, right? So that's the point that I'm making in the last part one bullet, is that you have short-term historical data, and then even if it's a few weeks, but you have future predictions of infection, right? You have for those few weeks past history, you have the COVID infections, and now your time series models can be making really good predictions, right? Now there are other ways to, when let's say when situation changes, right? There's going to be more lockdowns, even curfews. You can even add curfews, right? Very unfortunate, but those can be factored into these models in order to make your predictions much better. Now, going beyond COVID-19, well, some of this is also impacted by COVID-19, somewhat correlated. But the power of some of the products that we have is that even if you have, different variables that are correlated, we are able to use the ones that make sense, right, in the best possible way to build the best model. So, for example, you can add unemployment claims, things like, consumer price index, mobility data that's available right now. Now we see a shift of city dwellers going to rural areas, and also any other data that your organization has, right, that will apply to supply chain, right? So you can think of your time series model could be, built on so many different exogenous data, and when you're predicting, you can also make predictions on some of those, like, for example, like COVID-19 and the other ones, and that will help your models to forecast better, right? So this is something we talked about in the last few minutes. The short-term models can be power growth models, or a SEER type model, or a SEER transformer that works with AutoML in a product like driverless AI. And data can be provided for the last X weeks with input from COVID-19 data and other exogenous data, and then health forecast. Okay, so those are really good for short-term models, basically running into like maybe a few weeks or months, right? But what about long-term forecasts, right? So this is where things become highly uncertain, right? Even now, it's very uncertain what will happen in the next few weeks. Imagine projecting about a year ahead, right? However, for long-term forecast, the best way to do sort of predict what you might be doing is running what-if simulations, right? So you could run what-if simulations based on a wide variety of range of inputs or hypotheses, right? So you can say, hey, what if the unemployment rate varies from 20% to 30%, and then you can provide different, what if there's a second wave, what if the infection rate is 30% higher, what if something happens like the export import stops. And so basically now you're putting constraints on the not only you're putting constraints on all the exogenous values, and then runs different simulations to actually see yourself looking at the prediction surface on what are the different combinations of these exogenous factors are leading to different demand and supply things that you're really concerned about, right? So it's a very different way of I won't call it long-term forecast. That's the wrong way to say it. It's more of what if simulations to understand what are the different things that can go wrong in a constrained way, right? In the most reasonable constrained way. So let's talk about a really short term, right? Like, okay, so we build weekly forecasts and things are changing on the ground every day. And how do you sort of like start making day-to-day decisions on supply chain, right? So the forecast models are great, even with COVID-19 data and unemployment rate, etc. You can build short-term forecasts, but if something changes every day or hourly, we need to do something known as demand sensing, right? So demand sensing has been there for a while, but however, for folks who are new to this term, really what we're doing is that we are already doing the short-term forecast, but we're adjusting the output of that based on day-to-day and hour-to-hour and near real-time changes in the values, in the exogenous values, right? So you get a real big surprise, right, on some particular situation that your model is built on. Now we can adjust the predictions, right? So when I say predictions, I'm not talking about COVID-19. I'm something like a demand for, a particular product, right? Let's say hand sanitizer or a toilet paper, right? So everything is fine now, right? So all the stores are stocked with hand sanitizers and toilet paper, but what if something changes dramatically, right? So your short-term forecast says, all of this is going to be available, or all of this exists in your, it will be sold, but from a supply side, right? But something changes, now we can incorporate those changes into the model in order to adjust those forecasts. And that is called demand sensing. So I will give you a demo of both the short-term forecasting and the demand sensing. And if you have time, we'll do a little bit of what if scenario analysis as well. So let's talk about driverless AI time series forecasting in the next 10-15 minutes or so. And then we'll move on to the demand sensing demo. And then, like I said, if you have time, we'll cover some what if scenarios. So if you're not already aware, H2O has a product called driverless AI. Some of you may already be using it. We also have an open source product called AutoML, right? Driverless AI is a commercial product. And there are a lot of vendors in the space who do AutoML, and I've actually listed a few of them. One of the things that's very different about driverless AI is that it can do automatic feature engineering, right? Given all things are equal, we do some pretty advanced feature engineering, right? So if you have a data set, with all the different columns, like, for example, your SKU, your customer ID, I would just say anything, right? I mean, country, region, and then you also have COVID data in the X, right, created by another driverless AI model. And then you have unemployment rate, blah, 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 and you're trying to predict, the demand for some product, right? So you can actually bring the data into driverless through some of the most popular data sources are listed here, but you can, I know we have, 50 plus connectors to name it, right? So you bring a tabular data set, and then you can do some visualization, automatic visualization. I don't know if you have time to do that, but if you do a trial, check it out, because it's great for, looking at different visuals that we actually pull out that we think is useful to a data scientist, right? And then you bring the data X and Y, and we're trying to predict Y from X, right? That's what we're trying to do in predictive modeling. And then once you bring it in, we start an evolutionary process by which we evolve features like lag features in time series. And then we run multiple algorithms, do some hyperparameter tuning. And then the goal is to find the best set of features and the best algorithms, and maybe an ensemble on top of that. And it's completely, hands-free. That's why we call it driverless. It's a metaphor. So it's kind of like a driverless car. So you say where you need to go, and then it just drives the rest of the way. And then it's going to find the model with the best score possible, right? In this case, you see like the lower the score, the better. So it's finding a better and better model and features. So we are evolving both the features and the models, right? Like XGBoost or LightGPM, we're tuning that, right? And then we also have an option to bring your own algorithms and transformations. And so we have open source, maybe like, I don't know, 150 something different scorers and algorithms and transformations in our GitHub repository. And there's a link for that at the end of the presentation. And you can go there and see that you can just point to one of those and say, hey, there is a built-in set of algorithms that we ship with, and if you really want to add something on top of it, which we publish, regularly, you can just pull it into the product, right? Like if you look at a seared transformer, that is one example of what would be available as built-in going forward. But there could be another one coming up, maybe next month or in a few months, and you don't have to wait for the transformer or algorithm to come into the product. You can go to our GitHub and you can just add that as part of the tournament, right? And then may the best features and the best algorithms win, right? With the highest accuracy possible. We also generate an automatic scoring pipeline, which means that whatever models and features that we found during the evolutionary process, we actually write the code for you. It's compiled code that goes into a pipeline. So sometimes these pipelines could be pretty big. But remember, we're also doing a lot of cross-validation to avoid overfitting. So you're going to see like these features and models that get to the pipeline are already tested for overfitting. So all you have to do is deploy the Python or Java artifact, and then you can go to production with that, right? And make it part of your supply chain process, right? So you can think of driverless AI as the engine behind your supply chain automation. And also, we also have a product queue that I talked about earlier. You can also use that product that depends on driverless AI, the backend. And so you can create AI apps, purpose-built AI apps. So you run the predicting modeling in driverless, and then you sort of like interface to the user with a more friendly sort of app. So you have drop downs and things like that, and then you can actually consume the output of the automatic machine learning. The most important thing with driverless is the machine learning interpretability. So whether it's a time series forecast or a regression or a classification, we are able to break up, sort of peek into the model to see how it's making predictions, right? So we provide things like Shapley values and K-line output for regression and classification, and Shapley primarily for time series forecast. So you'll be able to say, hey, you know what, if you're predicting a peak 2 weeks from now and say, you know what, the demand is going to peak or the demand is going to tank, then you can say, why did this happen? And it will actually tell you like the reason why it happened is because of X, Y, Z, right? And you want to know that, right, before you recommend the business to make a decision. So that's what driverless AI does. And specifically with respect to time series forecasting, we talked about short-term forecast, long-term forecast, right? And now for short-term forecasting, when we build the models, we account for forecasting gap, and then we have a thing called forecast horizon, right? So let's say, Bill, you have 4 weeks of historical data, which is about maybe like a few days late or a week late, because sometimes it takes time to collect all the data, curate it, and put it in the data warehouse or the lake house, and then we bring it to the driverless. You're probably about a week late for whatever reason, right? I'm just making an assumption here. But if you're going to get it in the next second before, that's even better. But assuming there's a gap, now we can actually build a model to say, hey, I got a 1 week gap of data, but I want to predict for next 2 weeks. Then we'll build a model that optimizes your forecast for the next 2 weeks. And then if we say my forecast horizon is 4 weeks or 6 weeks, then we'll build a model that lowers the error per week for the next 6 weeks. So it's extremely easy to build, right? So I forgot to say that driverless AI also uses GPUs in the backend, not just for TensorFlow models, but also for LightGBM and XGBoost and even GLM. So your models are going to run really fast, okay? And then we have a cross-validation scheme, a lot of backtesting. This is not the case where you bring in one set of validation data and then you are doing a model based on that, right? It's all about automating the whole cross-validation. We actually move the windows, we enlarge the windows, we play with it until the model is robust, so you can use it for future, right? It's all about avoiding overfitting. And then we also handle time group columns, and this is a very powerful feature in driverless. And what I mean by a time group is that, let's say you have a department in store and you have an SKU, right, based prediction, then you can bring the historical data for all department, all stores, all SKUs, and throw it into the driverless across, maybe last up to 6 months, right? And then what we will do is that we look at it and we automatically detect that there are groups inside, right? Time series groups, think of multiple threads. And then we start building models accounting for different variations across different groups. So we don't build an individual model for each group. However, we look at the whole holistic picture, including looking at even using the group columns. The time group columns is our own feature by itself. And then forecasting individual, department store and SKU will probably be much lower accuracy than putting all of that together. So basically, we cross-learn across different time group columns. And so that's the power of driverless, right? And then we also do time series specific feature transformations. We do lag features, we do aggregation on exponential moving average, then we do aggregations, right? Like we talked about just now, we look at lags. And you can also incorporate exogenous variables like COVID numbers from another driverless AI model, right? Which means that it's not just a univariate time series, right? So you're looking at not only time groups from that perspective, but also we're looking at different columns. It could be numeric, categorical. It can even be text, right? Could be a Twitter text that might appear, right? Even though you may not be able to predict, what Twitter feed might come out. I'm just saying that if you have some NLP into the columns, then you can actually include that, and we'll take care of all of that for you. And the most important thing about driverless is, as we mentioned in the last few slides, right? You can bring your own features and models. Let's say you have a time series feature that you've been using in your model. You can import that, and it'll actually compete with the lag features, and sometimes can combine as well, right? And you can also bring your own models. Or most importantly, you can bring your own cost function, right? So if you have a cost function that penalizes certain things, then you can write your own in Python, and you can actually make that a model optimized for that cost function. So regardless of what you do, whether you bring your own or whether you use ours, you can always forecast a value with Shapley, right? So we compute Shapley values for predictions, and I'll show you a demo of that in a minute. Okay. So so we are about 30 minutes into the presentation. So I'll move a little quicker because we have a lot of ground to cover. So with driverless, we have different knobs: accuracy, time, and interpretability. And I'm going to show that in a demo. Maybe we should just go to a demo right now just to save time. And yeah, there we go. So I have some data sets here. Some training and test data set that I loaded from a Walmart Kaggle contest some time ago. So let me show you quickly what the data set looks like. So this is just weekly sales. I hope you can see my screen here. This is just weekly sales for over several months and quarters. It runs up to 2000, the data is from 2010 all the way till mid 2012. You can see how this is the overall sales across multiple departments and stores. So let's go and just look at store number 1 here. And that is store number 1 across all the different departments, right? So similarly, I know we are on Excel right now, but I want to show you quickly. Okay, there we go. So that's just store 1, department 1, right? So there are, the data looks something like this. So you have a store column, you have a department column. See if you can zoom in real quick. And then you have the week, day of the week, right? And then you have one day per week. I think it's a Monday. And then you have the weekly sales and some other variables, right? And also has a holiday column and some sample rate column. If if it's a holiday, national holiday, then you're going to have weight more, So we also handle weights across rows, so it's there. So now we want to build a predictive model, right? So we want to go back to, let's say, the spreadsheet, go to the chart here in a minute, and then we want to actually forecast the next 6 months. How is it going to look like? Not across all department and stores. We want to look at per store and per department. What will the forecast look like in one shot? Right? We're not going to build one model per department, per store. We're going to throw all of the data in, and driverless AI is going to do lag features on all of the threads, right? And it is going to create features, and it is going to build a model, and then we're going to predict. And because all of the data in the past, we can actually compare. The actual this was predicted and see how well it's doing, right? So I have a training data set here, right? So let me see if I can enlarge my screen here. And then we have a test data sets that we want to predict on. So we're on driverless AI. So I want to predict, right? I want to create a time series model. I'm going to go and say predict. And then I pick a target column, which is weekly sales, right? And then I'm also going to predict, use a time column, which is the date, right? And then one option is to actually include a test data set right here. And then what we'll do, driverless AI do, is actually build a model on training and try to predict on test right away. But I'm not going to do that, right? I want to show you like how to score on a test data set separately. So that's exercise. So I want to predict for 26 weeks, which is roughly about 6 months, right? You can also do this for a few weeks, no problem. You can even just predict the next week, but I'm going to do. And then we have 3 knobs here, right? Accuracy, time, and interpretability. So very quickly, you can read this up in the H2O website. The accuracy knob basically allows you to do more cross-validation, run more algorithms, right? More hyperparameter tuning, avoid sampling the data. There's many things you can do with the accuracy knob. Obviously, the lower the value, the faster you're going to build a model. And the time knob basically allows for early stopping, right? So for different early stopping iterations. So when we build a model, we'll take 1 iteration, we'll run multiple algorithms, we'll do some feature engineering, and then we move to the next. We decide what we need to do for the next iteration, and then we continue to improve the score, right? And obviously, if certain combinations of features and models are doing really well, we'll try to improve that, and that's a evolutionary process. That's impossible to do it manually, right? You need to have an automation tool like driverless to do that. So the time knob basically allows you to run more iterations, even if the score doesn't improve, right? So for now, if I set to 3, then what it's going to do is, after 5 iterations, if there is no improvement in the score, it's going to stop, right? It's going to wrap up and build a model, package it and get out of the experiment, right? The last one is the interpretability knob. The higher interpretability settings I have, the lower feature engineering is going to do. It's going to do very basic feature engineering, like one-hot encoding and things like that. Because it's a time series column, it will still do some lag, right? And when you lower the interpretability knob, it is going to do a little bit more advanced feature engineering. And again, no matter what setting you have, you'll always be able to build sharp values on top of that. And then you have expert settings where you can go and tweak more time series parameters. Like, for example, I want to actually consider the time group columns as standalone features. So I'm going to check that. So now every time group, department, and store will become a feature by itself, as opposed to being anonymous, right? So we don't want to, while it's important to look at the different threads, sometimes looking at the head is very important, right? Looking at what category it is under, and maybe there's some signal to that, something very specific to that. So, and then there are things to speed up your, holdout predictions. You can see that we also have a dropout mode for regularizing. And then we have various different settings. Again, most of the time you don't have to change anything here. But if as and when you become expert in time series models, sometimes you may have to make those calls, but you can always do it in driverless AI, right? So now for the expert settings, you can also incorporate recipes that are outside, from outside, like, and it's our GitHub link, right? So you can actually go here and go to our GitHub website. You can click there and you can see we have a whole bunch of transformers and which you can add to the model, right? Like I can add ARIMA, profit, right? I can add trading volatility, time encoded. So there's a lot of transform. I'm not going to do this right now because ARIMA and profit takes a lot of time to build a model and we'll run out of time. So we won't do that today, but you can actually go here if you really wanted to, and then, just cut paste the URL, right? And then you can say load custom recipe from URL, and you can type the link here, right? And then it should actually show up here, right? ARIMA should show up as one of the feature as part of the feature engineering. So ARIMA is better than our default recipes, right? And it's going to show up on top, right? Okay, so I'm going to kickstart the experiment, but before I do that, I want to show you, like, we have various different scorers, and you can also add your own scorer. My favorite is WAPE, weighted, absolute percentage error, which you don't have right now, but we can get it from the GitHub. But I'm not going to do it right now, but you can add it, right? And then once you do that, then the model is optimized for the scorer that you're building. So we have the time column, we have the target column, we have the forecast horizon, we have the settings. Let's go ahead and launch this experiment, okay? So right now, what it's doing right now is it's actually doing validation split. You can see that it automatically detected the department and store grouping that we never said explicitly, right? So, so that's the fun part, right? So when you are doing a time series forecast and you're working on, different regions or different departments or different SKUs, then you can just bring the historical data, as long as weekly data or daily data, something that you agree on, and you can actually throw it into the mix. A very popular question is like, what if there are like a lot of gaps in the time series? We had a lot of gaps in the time series, but if it's just too many gaps, you can always roll up from days to weeks or weeks to months, depending on what you're trying to build, and you should still get a good model. So while I'm building this, right, when I'm running this, driverless AI has already built a few models, right? We built like GM. Oh, and it's finding, you see, it's finding a lower RMSE, a better score, and it's progressing. So now for the very first model it built, you can see that it tried exponential moving average, and it came out to be the #1 feature here. And then the lower and lower models, the store and department itself become an important features. We automatically extract the day of the year, day of the week, and so on. And so for every model, the feature importance is going to change. But at the very end, you're going to get a model. Let me pick one with the lower score here. And this is a completed model. You can see like the validation score was 7,629. The last time I included a test data set, so it did really well with the test data set, right? So it didn't overfit, it did really well, right? Maybe a little bit underfitting, but you can change all of that, right? Now, if you want to score, right? So now we build a model, now we want to score on a new data set. How do you do that? So you can actually say score on another data set and then pick a test data set, right? And then the weekly sales of the test data set, this is the actual value. So when we are going to predict on this data set and then compare the prediction with the actual value weekly sales. So you can, I'm actually now scoring on the test data set. So what's happening right now is that the entire pipeline that was built is now used to score without you writing any code, right? So it's doing it, and then you can actually download the predictions, right? And then you can compare the actual versus predicted. You can also visualize the scoring pipeline. Again, some products, some of our competitors call this blueprint, but in driverless AI, we don't determine this ahead of time. We discover the pipeline as and when we do feature engineering and model tuning, and also doing checking for overfitting, right? The cross validation stuff. So this is a powerful one. So when you keep the settings really high, you're going to get a maze of this. Like you're going to get like a very complex pipeline, and they're all tested for overfitting and validation. So you're going to get a much higher score, and you can always control, what features can be in a model, what features go into the final model, or what are the different algorithms you can choose in expert settings, and that's how we do that. Okay, so now we build a model, we downloaded it. What else we can do, right? So let's go to our product queue. Let's check the time. We're about 10:40, so we probably have enough time to do a queue demo, I think. And then we can also do a demand sensing demo there, right? So I want to give a quick intro to Q, and then we will go into a demo, right? So what is Q? Q is, I think of this as, BI for AI, right? In some way, or whichever way you want to call it, right? And then there are different ways to look at it. So the Q has a very business-friendly citizen data scientist, if you may want to call it, like friendly interface. Where any business analyst can go in there, bring in the table, upload the data, right? And then we also have a lot, and then they can search on different things, and you can, build some charts and graphs and things like that. But you can do it less number of keystrokes, right? And there's a lot of autocomplete built into it. And the other thing it also does is it actually talks to driverless AI in the backend. So you don't have to get into the interface that I showed you. If it's too complex, then you can actually just stay on a table level, right click and say build a model, and just provide bare minimum, settings like the time interpretability settings and the time column and all of that, and then it's going to build a forecast model for you in driverless and bring the model back, and you can score directly on the Q interface, right? So it's a really nice, very light interface, if you may, and you get visibility. You can do data prep, you can do dashboards, you can do reporting. And the most importantly, it can actually support a lot of, you can build applications on top, right? You can build notebooks, and all the applications are written in pure Python, and we have a SDK for that. And then you can actually package your, your forecasting or whatever, and make it really nice with the drop downs and everything, and then you can give it to a business user to play with it, right? So their experience will be limited to looking at the output, looking at the graph, looking at the business metrics, as opposed to looking at the driverless models and things like that, that you as a data scientist can handle in your application, right? So the way it works is, so you have, this is the interface. I'm not going to show you how to log in, right? It's just a login and password. And you have these different tables. So let's go ahead and click on this table, okay? So these are time series data. You can see we have date, we have week, we have SKU IDs, customer ID, region, right? We're actually trying to predict, some value like sales on per customer, per SKU for this week, right? So this is kind of like historical data. Notice that we actually augmented this data with COVID data. Again, we also add a Twitter sentiment to it on that product, or just some market Twitter sentiment around the topic. We also have a search interface. You can say things like, I don't know, like COVID, hey, new cases per day, COVID. So again, see, I'm hardly typing anything, and I'm actually getting all of this, right? And now I can actually draw a chart directly, right? So I built two charts, right? Like line charts, just typing just a few letters. So the one here is actually, so let me see. Yeah, that's the average COVID uses cases per day, and then it basically does average per day, right? In this case. Now, if you want to add sales to this, right? I don't know if there's a sales here. Let's see, sales. There we go, sales, right? So that's sales, right? So let me go to the right side. So you can see like the COVID cases, there's no historical data, right, before this. However, the history starts here, but we are probably somewhere here, right? So this one includes both COVID cases current as well as future, as predicted by shared models. So some of this is actually predicted by our model, and some of this is actually, this is kind of like a forecast that came out of those predictions, right? So we have all of that. What we really want to do is that this is the forecast, right? Weekly forecast that is independent of the COVID values, but COVID values are added here. So what we're going to do is we're going to adjust the future forecast based on the COVID activities here, right? This could be, again, going beyond COVID, it could be any disruption like social unrest, government lockdown, whatever reason. You can actually bring that and then modify this forecast and adjust it to account for those, right? That's what we're going to do. And that's why it's called demand sensing, right? So how do you do that? So we have an app for that. We build an app, and this is again written in Python with nice UI. And then let's say we want to use that table. We want to say I want to include 3 sensing variables, and I want to create a dashboard, right? Now, from that data, we also specify, the different sensing variables, Twitter sentiment, right? So we have the region, customer column, and then we want to pick the target column. This is basically sales, right? So what we're doing right now is we're going to build a model, a time series model, independently of the COVID first, right? The COVID cases did come from a shared model, but when we build a time series forecast, we're just going to build it as if there is no COVID data, and then we're going to make adjustments to that data based on COVID, right? So that's what we're going to do. So we're going to use MAPE as a valuation metric. You can use RMSC or whatever. And then let's pick some regions real quick and some customers. And then we'll pick some SKUs of interest for these customers. Let's look at the dashboard and then look at the model sensing. There we go. Okay, so this is the COVID data, right? This is the actual sales. This is the actual sales, right? So we use this as a sort of like a test set, right? Just to see how well we are doing. And then you have the forecasted sales of the sensing model. So basically, this is the forecasted sales in the time series, and we're now adjusting the forecasted sales based on the COVID data, right? So we're actually learning everything here, and we're trying to apply that here in some way, and we're adjusting that. And that's based on, we do a little linear regression inside, and then we adjust that. The point being here is that you can have short-term forecasts like this, and then you can have an adjusted forecast based on, additional data, right? So now the forecast is much higher for this product, right? Because the COVID is going up. And this is the kind of thing that I was talking about. So you can do a naive time series forecast. You can also do a COVID forecast using shared models. And then you can have demand sensing to combine both to come up with a final forecast. And now, as from the business user, this is not a driverless AI interface, right? This is a very business-specific interface that can be created by your data scientist to provide you, the business user, the power of machine learning, right, powering these apps. So these are BI apps that use AI under the covers. So that's the purpose of it. So I think I'm about to wrap up right now. So I think I will pass it off to Shabad to see if there are any questions, and then we can go from there.
Thank you, Karthik. That was great. Thank you for doing a great presentation. We have some questions in the chat window. We'll try to get to all of them with time permitting. One question is the demand sensing app using driverless AI to make predictions?
Yes. It uses the driverless AI to make predictions for the time series model. And then in order to combine the COVID data to do the final demand sensing, we actually do that in the Q app itself, right? We're probably using a scikit-learn inside the Q app. So we're doing all the heavy lifting outside, the automatic machine learning and driverless. It does talk to the driverless. And then when the data comes back, we are actually doing the sort of like the mashup in the queue itself.
All right. What is the end-to-end implementation time for queue and driverless AI?
I think that's a great question, right? So for driverless AI model, probably like minutes or seconds. So I wouldn't worry too much about it. Once you have that, then that's going to do all the stuff behind, and maybe a few hours worst case, right? In case you're trying to build on a large set of data, like a terabyte of data or something. But for queue apps, anywhere between, it depends on the proficiency of Python for your data scientists and a little bit of training on how to use the SDK. Some of our data scientists who are experienced probably build it in like weeks, maybe like a day or so, sometimes 2 weeks. Sometimes if it's a very complex queue app, it could probably take a month or so, right? And if you have multiple data scientists working on it, so you should be able to get something going really quick.
Okay. I saw you were using driverless AI on AWS. Is it only available on cloud or can it be on-prem?
Yeah, that's a really good question, I would say. So driverless AI is available on all the 3 cloud providers, right? So it's available on Amazon, it's available on Microsoft Azure, it's available on Google Cloud, it's also available on-prem, right? For on-prem, it will run on NVIDIA boxes like Linux boxes with GPU, with Ubuntu, it's there, Red Hat, and then you can have GPUs with CUDA drivers, and yeah, sure, it can run on-prem. You can also run on a VM, if it's big enough, you can run on a VM as well.
Great. And what kind of queue apps do you have available? Is demand sensing the only one for COVID?
Yeah, we are building a lot of apps right now because we have. Let me show you, right? Maybe we have tons and tons of apps coming out. This is probably things like NLP Insights. You just call and we have apps on OCR. So this is like this is the one that we are building that's using just pure COVID prediction that we are actually helping different hospitals with. So there's like connectors to so many different data sources like Salesforce. We do MDM solutions. We do money laundering, anti-money laundering. You can see like, this. We also have a lending app to predict mortgage default, forbearance. Also, if you're talking to Salesforce, for example, you can do like leads intelligence. This is growing by the day. I forgot to say 2 more, which I will say it right now. Data augmentation, right? So when you have data sets from different data sources, we're building an augmentation app by which it automatically augments data. Like COVID would be a good example. You have a data set and then you have the COVID data and you just say, hey, go find all the data sets that I can augment with. It's going to go search through the table space and then go find and then merge it for you, even to aggregations. And then we have the cash flow forecasting app, which is getting really popular by the day, which is like financial forecasting is moving into AI and ML. And, we're building an apps around predicting your next, next few months cash flow, right? Like daily cash on hand or whatever, like your payables and receivables, and then also explained it sharply. So this list is growing, including clustering and yeah. So I would say maybe like 100+ apps. Short answer.
Perfect. Besides demand sensing, what other supply chain use cases could you solve with H2O.ai?
Yeah, that's a great question. So I showed you a slide before, right? Let's go back to the slide again.
Okay.
So there we go. So you see this? So manufacturing, Okay, so manufacturing, warehouse management, transportation, distribution, logistics. So the whole supply chain, all the domains that are around under the supply chain, right? Including part failures, right? It affects your supply chain, right? And then let's say you have a electronic device, something fails, and where the part came from, and what if there's a manufacturing defect, right? So wherever predictive models are employed and has to be updated, all of those, use cases around supply chain, you can plug in the automatic machine learning and queue.
Perfect. And I think we have time for one more question. In the current situation where the local and global supply chains are badly broken, how can AI help predict this ahead of time, and which AI model can help this?
Yeah, right now, last few weeks, COVID was the big uncertainty. COVID affects everything, right? Supply chain indirectly or directly affects, right, including number of employees coming to work, everything, right, including transportation. There are no planes available for flight, whatever you want to come up with, right? So, so there are different models that are outside machine learning area, like I showed you, like the power growth models and the seared models, just equations, right, to model that, and you can actually use them to come up with, try to fix something, and then bring those predictions into your automatic machine learning. Right, automatic machine learning is not going to go away. It is something you're going to do day in and day out, right? With whatever data you got. The question is, what kind of data you can augment your data, right? And there's a lot of third-party data now available. You can see, like in the marketplace, like mobility data, right? So there's so much available. So you can augment that with the AI/ML models.
All right, wonderful. I think that's all the time we have for questions. In the chat window, I did put a link to try driverless AI. You get a 21-day free trial. There's a link. And thank you, Karthik, for taking the time today and doing a great presentation. And I'd like to say thank you to everyone who had joined today. The recording will be made available shortly. And everyone, have a good rest of the day. Thank you.
Thank you.